This is 2000, AIME I Problem 10. Problem statement reads, a sequence of numbers x1 through x100 has the property that, for every integer k between 1 and 100 inclusive, the number x sub k is k less than the sum of the other 99 numbers. Given that x sub 50 is m over n, where m and n are relatively prime positive integers, find m plus n. Okay, so right away, something that I take note of is that since we have each of the terms in this sum being expressed in terms of, well, let's see, in terms of the other terms in the sum, it looks like it's going to be easier for us to deal with some variable, some substitution that stands for the sum we're working with. So right away, let's just go ahead and let S equal the sum from 1 to 100 of x sub I. Okay, and now we're given that, so each of the terms in this sum, each of the x sub i's, so each x sub k is k less than the sum of the other 99 numbers. So let's see how we can express that in terms of s. So we're told that x sub k is equal to, so k less than the sum of the other 99 numbers. So s equal to, so what is the sum of the other 99 numbers? That's going to be s minus x sub k, and then it's going to be k less than that. But now we have an x sub k on both sides. We can get an expression for x sub k. So adding x sub k to both sides, we get 2x sub k equals s minus k. So x sub k equals s minus k over 2. Okay, so each of the terms in the sum is equal to s minus k over 2, where k is the index of x sub k, or the term that we're working with. So now we can go ahead and express this sum s as a sum of all these x sub k terms here. So let's go ahead and write that. So the sum that we're working with, s, must be equal to, so s minus 1 over 2 plus s minus 2 over 2 plus dot 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 plus s minus 100 over 2. Great, so now we've gotten rid of the x sub k in the expression. We can go ahead and solve for s. So let's go ahead and do that. So we know that 2s, so from above, we know 2s is equal to 100s minus the sum from 1 to 100, and that's 5050. And if you're not sure how I got that, well, this is the 100th triangular number, and that's given by the formula. So t sub n equal to n squared plus n divided by 2. And if you want, I would just encourage you to go look up triangular numbers. But that formula gives us the nth triangular number. So we have 100s minus 5050 on the right hand side. So negative 98s equals negative 5050. So s must be equal to 5050 divided by 98. And you can go ahead and simplify this if you want. Doesn't really matter too much, since it's not actually what we're looking for anyway. What we're looking for is x sub 50. So let's draw a little line here. So we have s now. We're looking for x sub 50. Now, from this above formula here, we found x sub k is equal to s minus x sub k minus k, or x sub k is equal to s minus k over 2. So from that, we can write x sub 50 must be equal to s minus 50 over 2, which is the same as 5050 over 98 minus 50 all divided by 2. Okay, so now we can just create like denominators in the numerator of this big fraction here, divide it all by 2, and let's see what we get. So we have 5050 minus 98 times 50, times 50 over 98 over 2, so that's over 196. And then, so 98 times 50, let's just do that over here. So, well, 50 times 100 would be equal to 5,000. So 50 times 98 is the same as, let me neaten that up. 50 times 98 is just going to be 5,000 minus 100, so 4,900. So x sub 50 is going to come out to be 4,900 over 196, or 5,050 minus 4,900, so 150 divided by 96, divide both sides by 2, that's to be 75 over 98. You can't reduce that any further, and this is the form that we are looking for. 75 plus 98 gives us 173. And that's it.